Hi, boys and girls. This video is 5-3 practice problems. All right. You're going to want to turn to page 311 in your workbook. Okay. The first problems, they start off pretty easy. They're just asking you, is there a positive, negative, or no correlation? Okay. So for number one, we notice that this trend here is to go uphill, and we know Slope-Tube would call that a puff positive. So we say this one has a positive correlation. This one's just kind of like all over the place, all right? And apparently it doesn't have any, the number of books you borrow doesn't have any relationship to the number of fines you pay. So this one has no correlation. So it just doesn't really show a trend. We can't spell and talk at the same time, all right? Here, the number of repetitions you do and the amount of weight you can do in pounds apparently has a negative correlation. That's a nice negative. It's going downhill. So what does that mean? The more repetitions you do, the less weight you can do. If you're only going to lift 120 pounds, you can do it twice, but you can't do it 14 times, I guess. I guess that's how you read that. Car dealership revenue. Okay, revenue, how much money the car dealership is making over time. Well, this dealership seems to be making more money over time, and this is a positive correlation. So that's the first thing you'll be asked to do, is identify positive, negative, or no correlation. Then they're going to ask you to make some predictions here. The scatter plot shows the number of CDs in millions that were sold. I know this is so dated because who buys CDs anymore, right? That were sold from 2011 to 2016. Use the points 2, 2,485.6, and 6, 1,172.5 to write an equation of the line of fit in slope-intercept form. Let X be the years since 2010. Oh boy, I'm going to need a calculator for this one. I'm going to use the pink one today. Alrighty, so we're going to use these 2 points, as nasty as they are, to write an equation of the line. 2,485.6, and the other point is 6, 1,172.5. All right, the first thing we have to do is find slope, which is why I got the calculator. Second y minus the first y over second x minus the first x. Now I expect this to have a negative slope, okay, because I see that the number of CDs being sold has decreased, okay. That's what, I was saying, they're not that popular anymore. Now it's all about digital music. 1,172.5 minus 2,485. Probably should have figured this out in advance, saved you some time. All right, so for slope, I'm getting negative 1313.1 for the top number. The bottom number is 4, okay? I think we're going to go ahead and turn this slope into a whole number, so let's divide that by 4. And that gives us a slope of negative 328. I could put a decimal point 3. This is assumed to be over 1. I'm always a big fan of telling kids not to put decimals in their slopes, but don't let the course 3 kids know that I let you do this, okay? Because in higher math, sometimes you do. So this is our slope, all right? Now they want us to write an equation of the line in slope-intercept form. Well, we have a slope and we have 2 points, but we don't have a y-intercept. So let's use the point 2, 2,485.6, and our slope of negative 328. Let's just go with negative 328. And we're going to do y equals mx plus b. We're going to substitute 2 for x, this ungodly thing for y, and this for m, right? So y, 2,485.6 is y. Slope is negative 328. Our x-coordinate is 2, and we're trying to find our y-intercept, okay? So I could probably multiply that in my head, all right? 2,485.6 equals, it would be 16, carrier 1, 2 times 2 is 4, plus 1 is 5, and 6. So this would be negative 656 plus b. To get b by itself, we add 656 to both sides. That gives me 1, carrier 1, carrier 1, 11. Okay, so let's see. This is our y-intercept now. So I have an equation now. I have y equals m is negative 328, and our y-intercept is a positive 3,141.6, which looks about, where it's trending to go, right? Okay, so that does look like that would probably be our point of origin, okay? Let x be the year since 2000. Oh, I forgot to put the x in. X is right there. X is the year since 2010. If the trend continued, how many CDs were sold in 2019? Okay, so what we're going to do, they're saying if x is the number of years since 2010, well, how many years since 2010 is 2019? 9. So x is 9. They're saying what would y be if x was 9? So we would substitute. We would do negative 328 times 9 plus 3141.6. I'm running out of room here. Okay, now I do need a calculator. 328 times 9 equals would be 952 plus 3141.6. Oh, and this is a negative because that was a negative. All right, so let's see. We had 3141.6 minus 2952. We can estimate that there are 189.6. You can't sell 0.6 of a CD, so let's estimate 190. What is this? Million CDs sold in 2019. That would be our answer. It's a lot of work. Okay, that's why you're in algebra, so you can do lots of work. Okay, the data show the median price of an existing home from 2010 to 2015. Use the points, blah, 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 and blah, 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 to write an equation for the line of fit in slope-intercept form where x is the number of years since 2010 and y is the median price in thousands of dollars. Very similar to the last problem we just did. I'll try to make my work neater. First thing we have to do is find the slope. All right, so they've given us these 2 points. All right, I'm going to do second y, 275.2, minus first y, 226.9, over second x, which is 4, minus first x, which is 1. Okay, 275.2 minus 226.9. All right, so that gives us 48.3 over 3. And let's go ahead and write that as a whole number, 16.1. So our slope is 16.1. Okay, now we can use 1 point and our slope to write an equation in slope-intercept form. Okay, so let's use the point 1,226.9 and a slope of 16.1. So y is 226.9 equals m 16.1 x 1 plus b. So we have 226.9 equals 16.1 times 1 is 16.1 plus b. So we need to subtract 16.1 from both sides. 226.9 minus 16.1 equals, we know that b is 210.8 is our b. So our equation in slope-intercept form is y equals m 16.1 x and then plus b, which is 210.08. That's our equation. It's ugly, I know. All right, so that's what we did. That was A. Now B, if the trend continues, what will the approximate median price of an existing home be in 2025? Well, remember, X is the number of years since 2010. So 2025 is how many years from 2010? We're talking 15 years. Okay, so they're saying let x equal 15. X equal 15. Okay, so that will give us y equals 16.1 times 15 plus 210.8. All right, so we need to multiply 16.1 times 15, and that gives us 241.5 plus 210.8, which tells us $452.3 thousand in 2025. Average price of a house, $452,000. That's a lot. That's a very expensive house. Okay, enough of that. Now, I did go ahead and do these in advance because I'll tell you what, when it comes to deciding how I'm going to label a graph, I have the decision-making skills of a squirrel in traffic. So I did go ahead and do the graph labels in advance. And I'm not going to do all of these because you guys don't have time to watch me do all these. I'll make sure you have the idea. This is basically the same problem we just did twice. The only difference is now they want us to make a scatter plot to go with it, okay? And then they want an equation, and then they want to make a prediction. Okay, so here I've labeled this graph. The table shows the predicted annual cost for a middle-income family to raise a child from birth until adulthood. All right, so we're going to graph this. Down here is the number of years the child's been alive, and this is the amount of money you've spent on this axis. So at age 2, all right, and this is 1 and this is 2. So this would be at age 2, all right? You would have spent $12,940. So here's $12,900 would be very close to $13,000. So we're going to put a dot there. At age 5, $12,970. Not much difference there, huh? It got a little closer to 13. Oh, man. And let's see. At 8, 5, 6, 7, 8, this would be 8. Okay, it costs $12,800. All right, $12,800. It's pretty much like right here. And at 11, 13,000. This would be 11 right here. 13,600. 13,600 would be past the halfway point, so it's going to go up a bit. And then at age 14, you would have 11, that would be this one right here. You would have 14,420. So here's 14,420 would be like here. So we do have a trend, don't we? I think it's an upward trend. I don't know that I could draw a line of fit there. Make a scatter plot and describe what relationship exists within the data. Seems to me like the cost to raise a child per year stays the same until they start to get older. From 11, or well, maybe from 8 or 9 on, it increases. It becomes more expensive to have a kid. Use the points to find we have to write the slope. They're giving us 2 hideous looking points, 8, 12,800, and 14, 4,000. It's hard to make neat numbers with this, but I hate it when they go really badly. 14,420. Okay, our slope, second y, 14,420 minus the first y, 12,800, over second x, which is 14, minus the first x, which is 8. All right, 14,420 minus 12,800, 1620 on top. 14 minus 8 is 6, which reduces to 270. So what that means is that every time you go up by 1 year, the cost of having a child goes up by $270. It's not really factual because it's so steady right here and it gets so steep here, but it is a slope. Okay, If the trend continues, oh, well, I haven't written my equation yet. I just have m. Okay, so m is that. Now I need a b. So I'm going to use y equals mx plus b. I'll use the first point. Y is 2,800 equals m, which is 270, times x, which is 8, plus b. Okay, 70 times 8. 12,800 equals 2160 plus b. Subtract 2160 from both sides. And we get that b is 10,640. Okay, so our equation in slope-intercept form would be y equals, m is our slope, so that's 270, x, and our initial value is 10,640. Okay. Now, if the trend continues, what will be the approximate annual cost of raising a child born in 2013 at age 17? Okay, so 2013 at age 17. Okay, sorry about that. Okay, so they're saying that the child would be 17. All right, so we're going to make x be 17. 270 times 17 plus 10,640. I'm going to need pink again here. 270 times 17. All right, that gives us 4,590 plus 10,640. So the annual cost of raising a child at age 17, if the trend continues, will be $15,230. That's a lot. Okay, so here we're back to positive, negative, or no correlation. Okay, let's see, hot chocolate sales. Well, that definitely looks like it's going down. No one's buying hot chocolate when it's 80 degrees. This is a downward trend, so this is a negative slope, a negative correlation. This one's kind of all over the place. It doesn't really matter what the temperature is. The number of apples is not affected by temperature. So this is no correlation. This is clearly a positive correlation because it's going uphill. Positive. So the number of frozen yogurt sales goes higher as the temperature goes higher. That makes sense. Okay, so here we have another one of these really lengthy ones, and this video is already pretty long. I'm just going to kind of talk you through what you would do here. I kind of suggested labels here for your graph. This would be the number of years. This is the time, okay? It's a table that shows the average length in minutes of professional baseball games over time. It does look to me like the length of the game does increase, so this is probably going to be a positive correlation. So you would make the scatter plot, write the equation of the line and fit, where x is the number of years since 2005. All right, you notice they didn't give you 2 points here. You have 2 points, okay? Well, what you would do is when you draw your line of fit, you look for the 2 points that are closest to the line. Maybe I'll go ahead and draw the line of fit so you can see what I'm talking about. Let's see, your 05, which would be right here, and the length of time 169. So we'll put a point right here. All right, in 07, we have 175. It should be right here. 09, we have 175. 11, we have 176. 13, we have 184. 15, we have 180. And 17, we have 189. All right. To pick your points, take a ruler or something. And your line's going to be way better than mine. Pick your points that fall closest to the line of fit. I would probably go with this one and this one. 17 and 9. I would go with 09 and I would go with 17. They seem to be the closest points to a true line. That's how you choose your points. Then you find the slope. Then you write an equation in y-intercept form. And then you find the trend. You predict what will happen in 2021. Okay? How reliable is the predicted length of a major baseball game? That can go either way. It's up to you to argue that one. Okay. Here we have another one of these really long problems. We have median income, how much you make depending on how old you are. I would expect the older you get, the more money you make. So it's probably a positive correlation. Make a scatter plot, draw a line of fit. Determine whether the graph shows positive, negative, or no correlation. If it shows positive or negative, describe the meaning, just like what I said, the older you get, the more money you make. Use the table to write an equation of the line of fit, okay? Find the 2 points that are closest to the line of fit and use those to find slope, and then use the slope and one of those points to find a y equals mx plus b. And you have to write a y equals mx plus b. But then it says use the line of fit to predict the median income for 32-year-olds. So you use your line to make a prediction for 32, okay? Which would be like out here. It would be 31, 32, which would be all the way out here. So you would use the line of best fit to make that prediction. Okay, the scatter plot shows the average price of a National Football League ticket from 07 to 16. Determine what relationship, if any, exists in the data. Okay, it looks like a positive correlation. They're charging more and more for football tickets. I don't know why. I don't even like football. Use these 2 points to write the slope-intercept form of an equation. So they're ugly points. You find the slope. You find y equals mx plus b, and then predict the price of a ticket in 2030. That's going to be interesting to know. I can't afford a ticket now, much less then, okay? Describe the trend in the data shown in the scatter plot and the relationship between x and y. Well, that is a negative correlation. Describe a real-life situation that could be modeled by the given scatter plot. Explain your reasoning. This is me shopping. Okay, this is just my explanation. Here I am. I start my Christmas shopping with my Christmas Club check. And then as I buy more and more presents, my income, my Christmas funds dwindle until eventually they would hit zero. I always spend all my Christmas money. That's just my explanation. You can make up your own. And that's finally the end of this. Oh my gosh. Aren't you glad I didn't do all those problems? We'd have had to have two-parter. It would have been like part 1 and part 2. But go ahead on over to McGraw-Hill. I tried not to give you totally heinous problems. And I will see you in class.